students. Now we are starting with our major paper, Programming in C. You may have learned about the programming languages. At least you may know the basic concepts of the programming languages that you have learned in your school. So now learning our C programming. C, it seems a strange name for a programming language, but it is one of the most popular computer languages today because it is a structured, high-level, machine-independent language. So it allows software developers to develop programs without worrying about the hardware platforms where they will be implemented. The root of all modern languages, as you know, it is algol. The root of all modern languages is algol, and it was introduced in early 1960s. It was the first computer language to use a block structure. And algol gave the concept of structured programming to the computer science community. So, C was evolved from algol. C programming language was evolved from algol. C uses many concepts from this language, algol, and it has more added features and concepts also, and added the concept of data types and other powerful, more powerful features. The increasing popularity of C is probably due to its many desirable qualities. The foremost one is it is a robust language. C has a rich set of built-in functions and operators that can be used to write any complex program. And C is highly portable. This means that C programs written for one computer can be run on another computer with little or no modification. The C language is well suited for structured programming. Thus, it lets the user to think of a problem in terms of function, modules, or blocks. That means a program can be split up into modules. A program can be developed in a modular way using C programming language. This modular structure makes the program debugging, testing, and maintenance further easier. So a C program is basically a collection of functions that are supported by the C library. And we can continuously add our own functions to C library. With the availability of a large number of functions, the programming task becomes even simpler. So, with this introduction, we shall start with our first unit, character set in C. So, the characters in C are grouped as letters, digits, special characters, and white spaces. The character set means it is a set of words, digits, symbols, operators that can be used in a programming language. So C also supports a different collection of character set. These set of characters could be used in our programs. So mainly there are 4 types of character set: letters, digits, special characters, and white spaces. Letters, it includes all the uppercase and lowercase letters. That means a C program can include all the letters, uppercase and lowercase letters, and all the digits 0 to 9, and it can include all the special characters, all symbols. Special characters includes all the symbols, question mark, slash, single quotes, double quotes, braces, upward arrow, dollar symbol, etc. It can make use of any special characters. All the symbols could be used in a program. And white space also. White spaces including the blank space, horizontal tab, carriage return, new line, form feed, etc. A C program can make use of all these character set, all these symbols, numbers, letters, special characters, and even white space also. Many non-English keyboards do not support all the characters mentioned on the character set. The character set includes all the symbols that may not be possible with an ordinary keyboard. So ANSI C introduces the concept of dry graph sequences to provide a way to enter certain characters that are not available on some keyboards. So each dry graph sequence consists of 3 characters. 3 characters, there is 2 question marks followed by another character. So it is dry graphs or sequence of 3 characters, 2 question marks followed by another character, and that the compiler replaces with their corresponding punctuation characters. These dry graph sequences provide a way to enter certain characters that are not available in keyboard. So the examples of such dry graph sequences are given. For example, 2 question marks followed by the equal to symbol is translated as an ash number sign, and 2 question marks followed by a open bracket, it is equivalent to a left bracket. Same way for the right bracket. 2 question marks with a followed by a less than symbol is used for left curly brace. Similarly, 2 question marks followed by a greater than symbol is used as a right curly brace. 2 question marks followed by an exclamation mark is used for a vertical bar. 2 question marks followed by a slash can be used as a backslash, etc. For using a tilde symbol also we can use 2 question marks followed by a hyphen. So this facilitates, these dry graph characters facilitate the usage of more symbols that are not available on a keyboard. And the next one is C tokens. We know in a text, in a usual passage of text, individual words and the punctuation marks are called as tokens in an ordinary text or a passage. Similarly, in a C program, the smallest individual units are known as C tokens. The smallest individual units of a program are called its tokens. The programming language C has 6 types of tokens. As we see in the screen, it facilitates 6 types of tokens: keywords, operators, strings, constants, identifiers, and special characters. Now, let's see what is a keyword and identifiers. Every C word is classified as either a keyword or an identifier. Every word that we use in a program is classified as a keyword or an identifier. all keywords have fixed meanings, and these meanings cannot be changed in a program, in a C program. So the keywords are words that are used in a program with a specific meaning. The meaning of that word could not be changed. So keywords serve as basic building blocks for program statements. So it has a particular meaning and it is used for that specific purpose. The meaning of that words cannot be changed. So there are a total of 32 keywords in C, and always keywords are written in lowercase letters. So let's see what are the keywords used in C. Auto, switch, extern, continue, volatile, double, case, return, for, do, int, enum, union, signed, if, struct, register, const, void, static, break, type, short, default, while, else, def, float, goto, long, char, unsigned, size of. These are all the set of keywords used in C, and we could not use these keywords for any other purpose. The meaning of these words could not be changed. And about identifiers. Identifiers refer to the names of variables, functions and arrays. That means if any variable defined by a user are termed as an identifier. So identifiers are the names of variables, or it can be the names of any functions, user defined functions, or it can be the name of the arrays declared by the user. So these are user defined names, and this consists of a sequence of letters, digits with the letter as a first character. So it can be a sequence of letters or digits, but the first character should be a letter always. So these are all identifiers, or the names of user defined functions, variables or arrays with a sequence of letters, digits, and always it should be formed with the first character as a letter. The underscore character is also permitted in identifiers. It is usually used as a link between two words. In case we are using two long identifiers, we can make use of underscore as a link between the two words, connecting the two words. So as it is an user defined name, identifiers are always user defined name, whether it could be used as a variable name, function name or array name. It is always a user defined name. There are some rules for forming identifiers. Always the first character must be an alphabet or underscore. Underscore is also permitted as the first character for forming an identifier. The first character must be an alphabet or an underscore. It must contain only letters, digits or underscore. No other special symbols are allowed in forming an identifier. It must consist only letters or digits or underscore. Only first 31 characters are significant. It should be of 31 characters length, or if it is given as a long identifier, the first 31st characters are significant in forming an identifier. And it cannot use a keyword. As we said earlier, keywords are words that have a certain meaning, a particular meaning, and it is always used for a particular purpose. We could not change the meaning of a keyword. So a keyword could not be used in forming an identifier. And an identifier must not contain the white space. These are all important rules in forming the identifiers, because identifiers are important in our programming. we need to form various identifiers in our programming. So we should be aware of the rules in forming the identifiers. So it should be, the first character must be an alphabet or underscore, and it must consist of only letters, digits or underscore. Only the first 31 characters are significant in an identifier, and identifier could not be formed using a keyword, and it must not contain white space. So these are all rules in forming the identifiers. So we know a token is the smallest unit in a program, and a keyword is a set of reserved words used in a programming language, and the meaning of that should not be changed. And we saw a set of 32 keywords that are used in C programming. There are a total of 32 keywords. An identifier, and we have learned the difference between the keywords and the identifiers. Keywords are words that have a predefined meaning, and the meaning of that words could not be changed, and these set of words are used in a certain programming language. So C also contains a particular set of keywords that could not be changed by the user. On the other hand, identifiers are always user defined. Identifiers are always defined by the user. That means it is defined for our purpose. So it could define any conventional namings could be termed as an identifier that are used to name a variable defined by the user. It could be used for naming a function, user defined function, or it could also be used for naming an array. These are all user defined terms, and these for the naming of these user defined terms we can make use of identifiers. And there we learned a certain set of rules for forming the identifiers. Now let's go move on to the constants. Constants in C refer to fixed values and that do not change during the execution of a program. So C supports several types of constants. First one is a integer constant. An integer constant refers to a sequence of digits. There are three types of integers, namely decimal integer, octal integer and the hexadecimal integer. So constants, in C the constants are also known as normal variables, also like normal variables, and they are also called as literals. Constants may be belonging to any one of the data types. The syntax for declaring the constant is const white space followed by the variable name. There are different types of constants: integer constants, real or floating point constants, octal and hexadecimal constants, character constants, string constants, backslash character constants. So the integer constants, an integer constant refers to a sequence of digits. There are three types of integers, namely decimal integer, octal integer and the hexadecimal integer. Decimal integers consist of a set of digits ranging from 0 through 9, and it could be preceded by an optional plus or minus sign. For example, a set of digits 1, 2, 3 or 78, 0. These are all examples of integer constants. So an integer constant must have at least one digit. It must not have a decimal point. It can either be a positive or negative. No comma or blank are allowed within an integer constant. If no sign precedes an integer constant, it is assumed to be a positive. For example, as we said, 1, 2, 3, 78, or even 0, or it can also be a hexadecimal number, octal number, or also considered as an integer constant. Real constants, the quantities that are represented by numbers containing fractional parts like 17.548, etc., are called real or the floating point constants. So a real constant must have at least one digit. It must have a decimal point. It could be either positive or negative number. If no sign precedes an integer constant, it is assumed to be a positive number. No commas or blank are allowed within a real constant. For example, 215.0, 7.0, 8.9, etc. are all examples of real constants. Next one is the character and the string constants in C. A single character constant, or simply character constant, contains a single character enclosed within a pair of single quote marks. For example, 5, the number 5 enclosed within a single quote, or a letter X enclosed within a single quotes. These are all examples of single character constants. The string constants, a string constant is a sequence of characters enclosed in double quotes. The characters may be letters, numbers, special characters, and blank space. For example, hello enclosed within double quotes is an example of a string constant. The next one is a backslash character constant in C. C supports some special backslash character constant that are used in output functions. For example, the simple backslash n, that stands for new line character. So a list of the backslash character constants are listed in the table. Go through all the backslash character constants. We shall continue on the next class. Thank you.